All right, so we are given this figure, and we are asked to determine the moment of inertia, and the axis of gyration with respect to the x-axis. So the x-axis in this problem is right here. So what we'll have to do is divide this figure into a few shapes. So we have this rectangle here, this rectangle here, and this rectangle here. And I am going to actually label them. So this one will be 1, this one will be 2, and this one will be 3. I'm going to create a little chart so I can organize what I have. And then we need to find the area. Then we need to find y bar for each shape. And then we also need to find the distance of each shape's y bar from the x. So, distance from x. And since we need to find the radius of gyration, we're also going to need the sum of all the areas of the shapes. So I'm going to add another table so I can add the areas together. So now we have shape 1, shape 2, and shape 3. So the area of rectangle is pretty simple. So it's just base times height. So for the first one, the base is 8 millimeters times 24 plus 24, so that's 48 millimeters. And we get 384 millimeters squared. Now for 2, we have, for the base, is 48 millimeters times 6 millimeters. We get 288 millimeters squared. And for the final rectangle, we have 12 plus 12, which is 24, times 6. And together, that is 144 millimeters squared. Now, since we are adding them all together, we don't need to subtract any shapes. I'm just going to add them all together. Oops. So that would be 384 plus 288 plus 144 gives us 816 millimeters squared for the total area. Now we need to find the y bar of each shape. So for 1, our y bar from the bottom here will be, looks like 6 millimeters because of this, because this rectangle doesn't start at the bottom, so we need to add the 6. Then the y of that rectangle will be 24. So plus 24 millimeters. This will give us 30 millimeters. For shape 2, the y bar for this one is simple because it starts at that point that we're trying to find the y bar from. And then we just divide by 6 by 2, and we get 6 millimeters divided by 2 gives us 3 millimeters. And then for our third rectangle, it would be 6 plus the 24 plus another 24 plus 6 divided by 2. So 6 plus 48 because of the two 24s plus 6 divided by 2, which is 3. And together that is 57 millimeters. Now we got to take this y bar distance and figure out how far it is away from the x-axis here. So it seems that the x-axis is 30 millimeters. So that means that the y bar of our first shape is 0 away from the x-axis. Then for our second shape, we are going to do 30 minus 3, and this will give us 27 millimeters. And we'll do the same thing for 3, and this one is also 30 millimeters from the x-axis. So all we have to do is take away 30 from 57. And this gives us 27 millimeters. So now that we have all of our needed data, we're going to find the inertia. So I'm going to add another table. Oh, hang on. Yeah, I'm going to add another table to find the inertia for each shape. Oh, I don't need that. Okay, so shape 1, 2, 3, and then our inertia for that single shape. So I'm going to use this chart here, and because they're all rectangles, and I am trying to find the inertia from the x-axis, I'm going to use this equation here, which is 1/12 of the base times the height cubed. So the moment of inertia for these shapes is 1/12 times the base. So the base of rectangle 1 is 8. The height, which is 48. And that is cubed. Let me make sure. Yep, cubed. And so that gives us 73,000 millimeters to the 4th. And so since the second shape is also a rectangle, it's going to be the base, which is 48, times the height, that's cubed, divided by 12, we get 64 millimeters to the 4th. And 1/12, the base, which is 24, times the height, which is 6, and cubed, that is 432 millimeters to the 4th. Now we need to use the parallel axis theorem, which is Ix equals I plus the area of the shape times the distance from the x-axis. I'll make that just x squared. So for shape 1, that would be 73,000 and then the area, which is 384 millimeters squared. And since the distance is 0, this doesn't matter. So this is just the inertia. Now for shape 2, that would be 864 millimeters to the 4th plus the area, times 27 squared. This gives us 210,816 millimeters to the 4th. And for our third shape, 432 millimeters to the 4th plus the area, 27 squared. This gives us 408 millimeters to the 4th. So now that we have all our inertias, we just have to add them together. So 73,728 millimeters to the 4th plus 210,000 816 millimeters to the fourth, plus 105, 408 millimeters to the fourth. And this gives us 389,952 millimeters to the fourth. So this is our final inertia. Now we just need to find the radius of gyration. So using this equation, we'll get this radius of gyration. So this is what we just found, and then the total area, which is right here, will be plugged in right here. So kx equals the square root of the total inertia divided by the total area and kx equals .9 millimeters. And there you go.